In this part of the lecture we have very short and simple problem to consider. This is a problem from chapter 1, page 4, and it discusses the concept of nth root of unity. Nth root of unity, n is a natural number here. It's the complex number omega, such that the nth power of this number is just identity. The problem on page 4, well, we will study this problem in the full generality later when we come to exponential form of complex numbers. But on page 4 in chapter 1, we have to just consider the case n equal 3. That's a very simple case, and you don't need any exponential form for that, although you can do it with exponential form, but you don't need it in general. You can do it using the algebraic techniques, and that's very simple. So you take the equation w to the cube equal 1, you put it in the canonical form with 0 on the right hand side, and you realize that your expression factorizes like this. Of course, at this stage we use the well-known factorization identity. Well-known factorization identity plus b squared. This one. Right. Now, when you look at this factorization, you obviously have either first factor 0 or the second factor 0. First factor 0 delivers the root right away. It's the root w1 equal 1. And for the second one, you have to solve quadratic equation. If you follow the typical way we solve quadratic equation, any of that, you see that you have two other roots, which are indexed to omega 2 and omega 3, and you go negative b, which is this coefficient, plus minus root square of the b coefficient, take 4ac by 2. 4ac by 2, that's the expression like this. Very simple arithmetic. One take 4, it's negative 3, you take the root of a negative number, that's where, so negative 1/2, it stands for this one and this two, plus minus root 3 on 2, and because here negative 3, in this expression negative 3 is negative, you got your imaginary unit. That's all there is to this problem. We will need this problem in the next part of our lecture, where we will consider the sum of binomial coefficients.